Hi everyone, how are you? Good afternoon. Are you having a good time at reInvent? Yeah, me too. It's finally good to meet so many people, learn about them, learn about the unique challenges they're solving for their organization. It's amazing. But just like me, I'm sure you don't work from Las Vegas, or at least from MGM Casino, right? For your day-to-day work, related to work, you log on to your corporate VPN, and then you access your applications. What if I tell you that you no longer need VPNs, at least to access your applications? I'm Shovan Das. I'm a product manager in EC2 VPC team, and I am with Jess, who runs the VPN organization in AWS. And we are very happy to introduce a new AWS service called Verified Access, which allows you to connect to your corporate application without VPNs. I'm personally very excited about this service because it is our first purpose-built service using AWS Zero Trust principles. In this presentation, we'll see why we built this service. We'll explore how this service works. Then we'll explore the policy, how you can write policies, access policies, and then we'll wrap up with a demo. So at AWS, we believe that we should give customer a wide array of choices for their connectivity needs. No matter how they want to connect to their application, to their resources, to their workloads, it's possible. Most of our customers, they VPN their users to their on-prem. Then we provide site-to-site VPNs, Direct Connect, Cloud WAN, TGW, and through that, they connect to their applications. Then we heard from some customers that, hey, we don't want to take this extra hop, right? We want to directly connect to our applications. So we came up with AWS Client VPN. Then what happened? A few years back, we started hearing from customers that, hey, we need simpler connectivity. No matter where I am, from a simple web browser, I can access my applications. And at the same time, they said that I want better security. I want to have control over who can access my application at what particular time from what particular devices. So essentially, they were saying us that we need zero trust connectivity, zero trust network access. So what does zero trust network access mean? It can mean many things to many people, but at AWS, we believe that zero trust is a conceptual model, and you shouldn't just rely on networks or network perimeters. You should also use non-traditional non-network-based controls to provide access for your users to your application or any resource for that matter, right? So let's unpack how it looks. In a traditional networking model, it says that once you're on the network, you can access your application. But zero trust principle says that let's use other signals. For example, identity. Now, why stop at identity? Use even more. Start using devices. Use device posture and identity and allow the users to access your network. Why even stop at identity and device? You can even use more real-time contextual signals. Then the second thing is that once you are on the corporate network, traditional method says that you can always access any applications. Zero trust says that do continuous validation. Check the identity device posture with every request, right? So I try to access the application, it checks. Then next time I try to access another application or even the same application, the validation happens. So it's a continuous validation. Now let's see what it means from the connectivity perspective, right? How you access your applications. In a traditional model, if you're in the headquarters, you're connected to your corporate network, and then you can access all the applications which are in the corporate network. If you move out of your headquarters, let's say you're in a home, or if you're in this MGM casino, you log on to your VPNs, and then you access your application. Let's say you're coming up with a branch office in a new location. So first you connect the branch office to your corporate network, which might take few weeks, few months based on where you are trying to open the branch office. And then all the users in that branch office can access your application. With zero trust, what happens is that your application becomes the center of your IT universe, right? So you define how and when somebody can use your application. So you build perimeters around your application, not your network. If you're in the headquarters, you just simply connect to your application. The policy runs. If you're allowed, you go and access your application. If you move out, let's say you're working from home, so then you don't have to log to VPN. You just connect to your application through internet, and the application will do the validation and allow you inside. You come up with a new branch office. You just need an internet connectivity to the branch office. And then all the users in that branch office can access their applications. So that's connectivity. Let's look from the security perspective what it looks, right? So if somebody gets hold of one of your server, right? So then since the server is in your corporate network, they can use the server and potentially gain access to your applications. With zero trust, since we are saying that zero trust will do continuous validation. So first time you access your application, zero trust verifies. The next time you access another application, it will verify. You try to access the same application, it will again re-verify. So let's say if somebody gains access to one of your servers, then they will try to gain foothold into the application. But what happens is that either the identity or the device posture won't match. So zero trust will deny access to that application. Now, these are all known facts, right? So our customers have been trying to build elements of zero trust into their networks for a few years. So let's see how it looks like, how the current solution looks like. So you have the perimeter. So you protect the perimeter. So there is VPNs, firewalls, and other things that you manage. Then for remote policy, you have the VPN policies. Then the application developers, they go and integrate their application with the identity with the help of security team. So they get guidance from security team, what policy they should set, who can access their application. Showan can access only few applications, but somebody else can access all the application. So you set all those policies. Then there is a device policy. So the IT team goes and says that how a device is compliant, and only the compliant devices can onboard the network, right? So essentially what happens is that there are at least 3 sets of policies managed by at least 3 different teams. And at the end of the day, if you want to change the policy or if you want to add a new application, it can take you days or it can even take you weeks, right? So we heard all this feedback from our customers, all this need from our customers, and we came up with AWS Verified Access. So it essentially gives the users an easier way to connect, so they can access the application from anywhere. Then it helps the security team to have a better security posture, because it's based on AWS Zero Trust principles. You can define the access, fine-grained access per application, and using real-time contextual signals like identity and device postures, right? And from manageability perspective, it is simple, because you can manage policies for each application using all the signals at one single place. So now with a few clicks, you can add applications, you can make policy changes, so it just happens within few minutes, no longer days or weeks, right? So this is how it looked like previously. Now it's quite simple. Users don't need any VPNs. From security perspective, you manage all your applications at one single place. Now let's look inside verified access, how it works. So it does 3 things. The first thing is that we talked about the policies. It gives you control over each application. You can define unique policies for each application. Like members of finance team can access financial application only if they are using a compliant device with disk encryption on. And other users, every user can access the corporate IT help desk, right? So you can define those kind of policies. Then the second thing that verified access does is that it logs each and every access request, either allowed or denied. And this is quite valuable for many of our customers because now they can use that rich data and they can use it for troubleshooting, for audit, for compliance, or to investigate security incidences. And the final thing is that we are building an open ecosystem. We understand that moving to zero trust, migrating to zero trust can be hard. You are already using security systems like your identity provider, your device security provider. We want you to continue with them and just use verified access to control your access. So we want to simplify that journey. So we are building an open ecosystem. Now let's look the role of our partners in this verified access, right? So we essentially have three sets of partners here. The first is identity providers, which manage your corporate identity, where you define who is a user, what department, where they belong to. And we are working with all the major identity providers, helping them to integrate using standard protocols. Then you have device management. These partners, they manage the security of the device, the endpoint. We have partners like Jamf. We have partners like CrowdStrike who are doing this. So you can integrate with them and use their signals to define your policies. Then finally, we are also trying to work with partners who can give us more contextual signals, like location, behavior analytics. Because remember, the zero trust says that the more signals you will have a better security, right? So that's why we are working with other partners as well. We talked about the verified access logs. We have a set of partners who will consume these logs and give you rich insights, which will help you with the audit, compliance, troubleshooting, all those use cases. Finally, we have managed connectivity providers. So what they do is that they take our building blocks and they build a managed connectivity solution for you, connecting your users to your application. And these connectivity providers also work across other clouds. They work across your on-prem. So in the end, you get a holistic solution for your entire connectivity space, right? Let's deep dive into how you integrate with each of the partners. This is the identity partner. We have three ways you can integrate. If you are already using an identity provider, you just integrate with the AWS IAM Identity Center. So that acts as an identity hub. And we are already integrated with them. So we get all the user information from them. The advantage is that once you have bring the identity to Identity Center, now you can use those identity across many different AWS services, like Verified Access, Grafana, IoT. The other option is that, yeah, you can just use Identity Center to manage your, if you don't have an identity provider, so you can just use Identity Center to define your user pools, manage the user pools, things like that. And finally, you can directly integrate your identity provider using OIDC with AWS Verified Access. From device management perspective, many of our partners, they run an agent in the device, right, which monitors the device, defines it is compliant or not. So we have come up with a browser extension. The user uses the browser extension in their device. The browser extension communicates with our partners' agents, gets all the information if the device is compliant, what is the OS, things of that nature. And when the user access their application, when they send the request with the HTTP request, our extension also sends the device claims. Now, if you are not using device claims in your policy, you don't need this extension. You can just use a standard browser, the browser you are using, so it will work. Only if you are using device claims in your policy, you need the browser extension. So let's talk about the observability partners. So they already have a service. Now what we are doing is that we are putting all our logs in a standard schema, which is called OCSF, which we released in August with collaboration with industry partners. The problem is that how do you store the logs in a standard way, and how do the partners can consume the logs and give you richer analytics, AI/ML-based analytics. So that's why we came up with this standard schema, and Verified Access uses this standard schema, and it simplifies our life because we can provide logs in a standard schema. It simplifies the lives of our partner because they can consume and give you all the richer insights, right? And these partners, they consume logs from your SaaS application, your on-prem application, many different sources. And they will combine all the logs and give you the richer insights that will enable all the use cases that we talked about. So let's look at the managed connectivity partners. These partners, they were using AWS services like TGW, Cloud WAN, Route 53, Private Link, and then they were helping you to connect your VPCs to VPCs, your on-prem to VPCs. Now these partners can actually take verified access, and then they can connect your users to your application using zero trust principles. So you will get resource-to-resource connectivity, you will get users to application connectivity now. And these are our partners. And we are very thankful for our partners for collaborating for the last 1 year with us. If for some reason you don't see your identity provider, your device management provider in this list, please contact us. We are happy to work with your partner and onboard them to this ecosystem. So now many customers say that, hey, Shovan, this is great. Zero trust is great. We want to move to zero trust. But how do we move to zero trust? How does the migration look like? Is it complex? So actually in AWS, we have gone through this migration for the last 5 years. So based on those patterns, our recommendation is that if you're coming up with a new application, like a greenfield application, so put it behind verified access. So those are taken care of. Now you might have many applications in the VPN already, so you have your policies which is working, and you don't want to touch them. So keep them on VPN. But also add them to verified access. What happens is that now your users will get a public path. So if they're on the corporate network, they come through the corporate network. If they're outside, they get this public endpoint and they come through the zero trust. So you get both paths, and at some point in time you will be comfortable when your incidences are less and you feel really comfortable, then you can turn off your VPN and migrate all your applications to verified access. So let's look how verified access works. Actually, it's quite simple. You just need 4 steps to do it. First, you create a verified access in the region where your application lives. Then you connect to our partners. We talked about identity providers, device management providers. So now verified access can get the data from them. You might have hundreds of applications in different accounts, different VPCs. You add or associate those applications with verified access. And then the default policy is deny all. So then the final step is that you go and write policies. And we'll talk more about how you write policies. So once you do these things, the users can connect from their laptop. And you don't even have to change your application name. The same application name is there. And the user just type myapplication.com, and they're connected, right? So at this point, you might be wondering, like, hey, what is a corporate application actually? How does it look like, right? So corporate applications are applications which are developed by your engineering team using AWS resources. These applications can be like your corporate directory, or your financial dashboards, or your IT help desk system. These applications are actually, most of these applications are front-ended by a load balancer like application load balancer, a network load balancer, ENIs. Now these applications front-end, they are in the private subnet because you want it to be accessible only through your private network, right? So now you can move these applications to verified access. You get 2 things. You get your users can connect the applications from anywhere, and you move to a zero trust based architecture. In some cases, the target is already in a public subnet. The ALB is already integrated with OIDC providers. You can move these applications to verified access. You will get 2 things out of it. The first is a better security posture, because now you can combine device states and define policy based on devices. The second thing is that you will simplify your management, because all applications and all their policies are at a single place. So you can define policies, manage policies, audit policies at a single place. Now, this is my favorite feature actually on the entire, and I will talk more about this. But let's say you have an application. Your application name is myapplication.com. When you add that application to verified access, what happens is that we create a public endpoint. So it gets a DNS name and IP address. But you don't want your users to change when they type the application, you don't want to type a different domain name, right? So you do the CNAME mapping. So you take this domain name and do the CNAME mapping. Whenever they type the application name, all the request comes to verified access, and verified access will evaluate based on your policies and then connect. The final thing here is that we drop a point-to-point network interface between verified access and your application. So we do the connectivity. Few months back, when I was working with our doc writer said that, hey, Shovan, tell me what route tables we need to document. What do the users have to configure in the route tables? Should they use VPC peering or some other connectivity? Tell me about that. And I told them that, yeah, it's actually magic. You don't need anything. We will connect this hyperplane ENI and get the connectivity for the users. So it's actually quite simple. Just point-to-point connectivity. You don't have to do anything in the back end. We take care of everything. So now let's talk about the policies, right? Although verified access gives you control to define policies for each application, but you don't want to write 100 policies. So our recommendation is that you group applications with similar security needs, like financial application in one group, IT application in another group, and you define one single policy for these applications. In some cases, you might say that, hey, I have an application which has a different security bar. That's fine. All the financial applications have a single policy, but this one I want to have some more tighter control. So in that case, you can optionally put one more per application policy on it. So that's actually a good segue. We'll talk more about the policy, and I'll hand it over to Jess, who runs the VPN organization. Thanks, Jess.
Hey, I'm Jess. Like Shovan said, I'm the general manager of the VPN organization. I am so excited to share this product with you. I've been working on this for a while with Shovan and the team. This is a really exciting thing to bring to you. So looking forward to your feedback, looking forward to you using it and telling us what works and what we need to work on. So let's talk about writing policies. With Verified Access, we are using a brand new policy language that AWS has built called Cedar. We and Verified Permissions are the first two products to use this. So let's talk about what Cedar is, why we chose it, and how to use it some. So Cedar is, like I said, a new language. It looks like this. You write permit and forbid statements, and together they control access to your application. Cedar is a language that was built by our automated reasoning group. Why did we build this? There's a lot of policy languages out there in the world. In fact, we have a really fantastic one that we use in IAM all the time. We call it Balsa. It turns out that Balsa is a really effective language, but it's really designed for accessing AWS constructs. So when you're using it to combine data from third parties together to talk about your corporate applications, it wasn't the best fit. We would have had to change it outside of recognition for it to be really effective. So then we looked at open source options out there, and even some options from our competitors. And it turns out that those options didn't fit a set of criteria that we had for what would be really effective. So when you're either creating or choosing a policy language, we think there are three really important criteria for what makes a great policy language. First, it has to be expressive. You have to be able to write the policies that are important to your application. You have to actually be able to create the controls that you're looking for. Second, it has to be strict enough to support static analysis and debugging. We've introduced products like IAM Access Analyzer and a Network Analyzer to help you understand what's going on in your systems in AWS. And we feel like we need to hold the same bar here for verified access. So the policy language has to be analyzable, strictly debuggable, and support making great decisions based on it. Finally, it has to be fast enough to run in the real world millions of times a minute. We obviously process an incredible amount of scale at AWS, and we expect you to be pushing us on that side too. So our policy language has to be really fast. So Cedar uniquely fits all three of those constraints in an effective way for us. So let's look at how you write it. So Cedar syntax is straightforward. First, you define an effect, either permit or forbid. Then you define a scope. This is where you can map your business domain to Cedar through principles, actions, and resources. And finally, you create a condition clause. This condition clause allows you to write arbitrary logic against the data that Cedar is processing in the evaluation request. So the scope, in particular, I think is really interesting if you're using verified permissions and using Cedar inside of your own applications. The challenge with verified access, or as you're going to hear me call it more, AVA, AWS Verified Access, the challenge with AVA is that we don't always understand your business applications. We're creating a connectivity path. So for us to model your principles, actions, and resources, it didn't make as much sense for us. So you'll find that when writing policies with AVA, you don't use the scope section. What you do use is the condition section. So what happens is that when we connect to your trust providers, we bring all of their data into the context, and then you can write logical statements between all of them together. So let's go deeper on how that context works. So as I mentioned, when you connect your trust providers together, they send us data. You can think of this as a JSON object. In fact, that's usually how it comes in, as a JSON object. You also provide us a policy reference name. This is just some string that you create to help you write policies and connect these together. So for example, here I have user data and I have device data. We then take those keys and map all this data under the context. So that lets you then refer to these data together when you're writing a policy. So for example, I might permit when my user's email is verified and my device risk is low. Or I might forbid if my user's email address is from some untrusted domain or the device risk is high. You can see here that this provides you a lot of compositional capability, and we think it provides you an incredible amount of power. Cedar gives you a lot of operators out of the box. There are logical operators like equality and or not. There are numeric comparison operators. There's a like operator here to do a string comparison. There's a has operator to see if a property exists on an object. And there's a contains function to check to see if an item is in a list. There's more beyond this. The Cedar documentation has all the details. This is what we think we're going to use most frequently with Ava, though. So let's look at a few examples to go in a little deeper. So this example, I am permitting access when my identity groups contains finance, and my device's overall assessment is greater than 80. So one thing to keep in mind here is that I'm showing you example data. The data that comes after the context entirely depends upon the trust providers that you've connected. So these shapes of data can really vary. This is sort of exemplary of what we've seen in a few cases. So in this case, this says allow access when the user's in the finance group, and the device has an overall assessment over 80. Here's another example. Permit when the email address is in the example.com domain, and the device risk is low. This says permit posts when the user is in the administrator group, and their device is patched, potentially. And this one, finally, is forbid if the device's manufacturer potentially is from Shady Corp. One thing to keep in mind here is that Cedar allows access if at least one permit statement matches and no forbid statements match. One thing I really like about using Cedar is that it creates an isolated execution environment for your security policies. I know if you've worked in security for a while, you think a lot about the various kinds of attack surfaces that you create by running code. Well, in this case, we're running Cedar in a completely isolated space. It's a very limited language. There's only so much an attacker can even attempt to do before they even get to your application. So for example, if a request comes in and Cedar evaluates it, and you get a permit, then the request is proxied to your target. But if a request comes in, and if there is a forbid, or if Cedar has any error processing the request, then the request just simply isn't proxied through to your target. So we think this protects you from an entire set of classes of attacks and helps you be more secure. OK, great. So let's see what it looks like to actually use Ava. So in this example, I'm going to have a private application running in a private subnet. It's got an ALB in front of it and a set of instances. We can call it some finance application, maybe a general ledger application. So the first thing I'm going to do is I'm going to go to the VPC console. Verified access lives inside of the VPC console. I'm going to look on the left side for the new verified access area, and I'm going to start creating a new instance. When I create a new instance, I give it a name and a description, and then I go and I start to pick a trust provider. Now, I haven't created a trust provider yet, so I'm going to click on Create Trust Provider. That'll open a new tab. This trust provider, I'm going to connect to AWS Identity Center. So I'm going to start by giving it a name, the Identity Center trust provider, and a description. Now I'm going to give it that policy reference name. Like I mentioned earlier, this is the key that I'm going to use when I'm writing context, or when I'm writing Cedar policy that references the context. So in this case, I'm going to say AWS IDC. I'm then going to select that it's a user trust provider and that I'm using Identity Center. And because I already have Identity Center configured, it's ready to go. I don't have to give it anything else. As Siobhan mentioned, we do also support OIDC connections. And in those cases, you would fill in all the OIDC details provided to you by your provider. So I click Create. That creates the trust provider. Then I go back to my instance. Now I can refresh the trust provider list, and I can select the Identity Center trust provider from the list. I create that instance. The next thing I need to do here is to create a group to hold my application. Like Siobhan mentioned, groups are a way to have a similar policy that applies to all applications that live inside of that group. So I'm going to go to the Groups tab, and I'm going to click Create Group. In the Create Group screen, I'm going to give this group a name and a description. I'm going to call this one Finance Applications. And then I'm going to select the instance that I just created. And then I'm going to go ahead and start writing a policy. So for this policy, I'm going to say permit access when the IDC groups has this group ID. So this group ID feels a little strange. You can see here that Cedar does allow comments, so you can write a comment to make this easier. But why am I writing this group ID? Well, when I get data from Identity Center, the Cedar context actually has this data structure inside of it. So you can see here that it's got user information, and it's also got group information. So when you create a group in Identity Center, you can give it a name. The thing is that you can then change that name. So if you change the name and you don't change your policy, then your policy doesn't work anymore. So referring to the group ID here actually gives you the value to be flexible in Identity Center and not have to update your policies. Getting that group ID is actually also really straightforward. So if I go to the Identity Center console and I look for the group that I want to reference, if I click into that group, then I see that it has the group ID right here on the screen. So I can copy that and use that in my policy. So now I'm going to create an endpoint. I've created that group. Next thing to do is create an endpoint. This is what actually holds the connection information to target my private application. So endpoints are regional resources also. So if you have applications in different regions, you create different endpoints for those different regions. So I'm going to go back to the Verified Access console. I'm going to click on the endpoints screen. I'm going to then create a new endpoint. So there's a number of fields on the screen, so I'm going to walk through them. So first, I give it a name and a description. And then I'm going to choose that finance group that we just created. The next thing for me to do is to start to fill in application details. So the first thing that I have to give Ava is the domain name that I want my end users to use when accessing this application. Like Siobhan was talking about, that using that same name that they've been using on the VPN, you can put that name here, and then we'll be able to create a public access path to that name. So in this case, my domain name that I'm using is testava.endpoint.schmeida.people.aws.dev. This is sort of my test hosted zone. I imagine you'll have an easier domain name to work with. So I type that in here, and then I have to select the certificate to use for Ava to secure that endpoint. In this case, I don't have one ready, so I'm going to go create one with ACM. So I'll just show you that flow really quickly. It's pretty straightforward. This is one of the things I love about ACM. You can go click in Request a Certificate. I'm going to request a public certificate, and then click Next. Here, I'm going to fill in that same name that I'm going to use as the public DNS name for the endpoint. I'm going to select DNS validation, because that's the easiest way for me to validate that I actually do own this domain. And then it'll start going into a pending state. ACM gives me a CNAME and a CNAME key and a CNAME value that I need to go put into my zone. So the next thing I'm going to do is I'm going to go put those into my zone, come back to ACM. At that point, it will have noticed that I've actually owned that zone. It'll have issued me the certificate, and then I can take the ARN that it's created for that certificate. So I take that ARN back to creating my endpoint. I click refresh from the list, and now I can select the ARN that was in the list for the certificate. The next thing I need to do when creating the endpoint is to fill in the endpoint details. This tells Ava exactly how to connect to your application. So the first thing that I do is I select the attachment type. Right now, we support VPC attachment types. In the future, we expect to add other kinds of attachment types, for example, with Transit Gateway or Cloud WAN. We're also looking for feedback if there's other things you'd like to see us support, so please do talk to us. The next thing I do is I select a security group to associate with this endpoint. This security group will be associated with all traffic that's exiting from Ava towards your application. You can then use this security group in your application's security group, for example, with security group referencing, to further restrict the amount of traffic that can reach your target. So this helps if you're, for example, onboarding applications to Ava over time to Zero Trust. You can keep them in the same VPC and then use security groups to help reduce the amount of other traffic that can reach them. The next thing I do is I give Ava an endpoint domain prefix. This is a little bit of text that we're going to prepend to that gobbledygook DNS name that we create for your endpoint. So when Ava creates the endpoint, we create a DNS name that Siobhan mentioned that you put into your zone to actually do the redirection. This little domain prefix helps you stay organized. It's just a little bit of extra text, helps you keep track of all the different CNAMEs that we're going to be creating for you. The next thing I do is I select the endpoint type. Today, we support load balancer types, and we support network interface types. And as Siobhan mentioned, we support application load balancer, network load balancer, and any elastic network interface. So in this case, my application is a load balancer endpoint, so I'm going to select load balancer. I'm then going to tell Ava what kind of traffic to emit towards that application. We can either emit HTTPS or HTTP traffic, and it can be on any port. So in this case, I'm just going to choose HTTP on port 80. Now I select the load balancer that I want to direct traffic to, and I tell Ava which subnets to direct traffic over towards that load balancer. These are just the subnets that I've already configured on my load balancer to listen on. Then I hit create. Well, I'm sorry. Then I get to write a policy. In this case, I'm not going to fill in a policy. But as Siobhan was mentioning, you can add a policy here to further restrict the kinds of traffic that can reach your target. If you don't write a policy on the endpoint, then only the group policy will be evaluated, and that will determine access or not. If you create a group policy and an endpoint policy, then both policies will be evaluated, and they have to both permit access to allow access to the target. So now I'm going to create my endpoint. So the next thing that Ava does is that it puts the endpoint into a pending state. It takes us a minute to spin up all the resources, so let's look under the hood while we wait. So as you know, Ava sends traffic to your target application. But how does it do that? So when you create an Ava endpoint, we actually create a VPC just for your traffic. This VPC is for your verified access instance, and only your verified access instance. We do not commingle traffic. We build a load balancer inside of that VPC, and we build a multi-AZ configuration to be able to pass traffic to your target. As Siobhan mentioned, we put a hyperplane ENI inside of your subnet, inside of your VPC. And that's what you're going to see in your VPC that is sending the traffic to your application. We then wire it all up. As I mentioned, each Ava endpoint is a regional resource. And obviously, it's always in the AWS cloud, so we keep your traffic secure. So my endpoint is pending still. So next thing I'm going to do is set up that DNS CNAME to pass traffic to my target. So I'm going to copy that gobbledygook CNAME that Ava created for me. You can see here that it's prepended with that test little bit of text that I gave Ava. I'm going to take it over to Route 53. I'm going to update my zone. I'm going to add a record here. I'm going to create a CNAME record. So I'm going to first fill in that public name that I want to give to my users. I'm going to select CNAME from the list. And then I'm going to fill in the name that Ava created for me. I'm going to hit create. OK, so now my endpoint's active. Let's give it a shot. First thing I do when I put in that public name on my browser is I get redirected to AWS Identity Center's login screen. Again, this is because I'm using Identity Center as my trust provider for user login details. So I'm going to go ahead and log in, fill in my username and password. And then, because this user that I logged in with is in that finance group, I get access to my super secret data. So that's really great. But a lot of the value that we provide you is the ability to connect multiple data sets together. So how do I actually integrate device data? Well, I start by creating another trust provider. So I'm going to go back to the VPC console and select trust providers. I'm going to start creating a trust provider. And I'm going to do this twice. First, I'm going to create a trust provider for Jamf. Jamf has been a really fantastic partner to work with. We've been really excited to be able to have them help us create a more secure infrastructure for you. So first, I'm going to fill in the name and the details here for the Jamf trust provider. Then I'm going to give the policy reference name of Jamf, just to make my life easier. I'm going to select that it's a device trust provider, and I'm going to choose Jamf from the dropdown. And then I'm going to fill in a tenant ID. This is a value that Jamf will give you to help Ava connect to Jamf and under the right customer ID. I'm going to do the exact same thing here now for CrowdStrike. We're also super excited to bring CrowdStrike to the table with you. So Jamf helps you protect your Apple devices. In this case, I'm going to have CrowdStrike be protecting my Windows devices. So I'm going to fill in the policy reference name of CrowdStrike. I'm going to select that they're a device trust provider and choose CrowdStrike from the list, and again, fill in a tenant ID from CrowdStrike. Now I need to attach these trust providers to my instance. So I'm going to go to the Trust Providers tab on my instance. I'm going to click Attach Trust Provider. And then this pop-up will come up. And so 2 times, I'm going to select each trust provider, and that'll be attached to my instance. So now I need to update my policy. It's all great to attach these data, but I actually have to have a policy that references the data. So I go back to my Finance Applications group. I click on the Policy tab, and I click Modify. This then opens up the policy editor. So you can see here that I'm adding some data to my policy. I'm still going to keep that AWS IDC reference to see if they're in the finance group, but I'm also going to add a stanza that looks at both CrowdStrike and Jamf. So if a device is coming to Ava, it's going to populate the context with one or the other bit of data. So the first thing I have to do is check to see which data is there. So first I look, does the context have the CrowdStrike key, or does it have the Jamf key? Only if it has one of those keys do I then do the next evaluation. If you're familiar with short-circuiting, this is what that ampersand is doing. So in the CrowdStrike case, I'm going to see if the overall assessment is greater than 50. CrowdStrike gives me sort of an overall out of 100 assessment of the security of the device. In the Jamf case, I'm going to see if the risk score that Jamf has given me is either low or secure. Jamf gives me an enum value with a number of different risk indicators. So I like secure devices. So I'm going to save that. Ava is then going to go mark all of my endpoints that are affected by that policy as updating. So it's going to take a minute to apply that policy. So before we test it, how does Ava actually get that data from the device? Well, when you configure a device with either Jamf or CrowdStrike, you install an agent, like Siobhan mentioned earlier. This agent talks to the provider and manages the device's configuration, reports back, and is generally how they deliver their service. One of the things that both of these providers do is they put a bit of encrypted information on the device that holds the information about the device. So then when you create an Ava endpoint, when you give us that tenant ID, we then go and talk to the provider and get a decryption key from them. We hold that securely for you. You then install that browser agent, like Siobhan mentioned, so that when a user makes a request, the browser agent talks to the local agent on the device, gets that bit of secure information, and then passes it along with the request to Ava. We then use that decryption key to read the data in that token and then give that to you in the context. Great. So my endpoint is updated. So I'm going to try accessing it first from a device that I haven't actually registered with my trust provider. So in this case, even though I've installed the browser plugin, you can see here that I have the Verified Access browser plugin, I actually don't get access, because there's no agent to read that encrypted bit of data from. Now, on the other hand, here's the EC2 Mac instance that I spun up. If you haven't tried EC2 Mac yet, by the way, it's a fantastic service. It's a really great way to test things, to build applications, and we're really excited to bring it to you. So here I've installed Jamf Trust. You can see here from the icon running in the sys tray. I've also got the Verified Access plugin installed. You can see it's working because there's the green check. So when I go to the application, I then get, again, redirected to the Identity Center login. And when I log in, now this device was evaluated as secure, so I get access. So let's take a minute and talk about logs. We support 3 log targets, either CloudWatch logs, S3, or Kinesis Firehose. We will emit 3 kinds of log entries towards those targets, either access allowed or 2 kinds of access denied messages, depending on why the access was denied. Let's set it up. So we can go to the instance and navigate to the Login Configuration tab and click Modify Login Configuration. This login configuration applies to the entire verified access instance, and so all groups, all endpoints in that instance will log to the same target. I then select the toggle for Deliver to CloudWatch logs, and I select the log group that I've created earlier called Ava. I click Modify, and now logs are being sent. So Ava sends logs in a very verbose format that is called OCSF. As Siobhan mentioned, OCSF is an open standard of logging schemas. The huge value that we see here is that this enables your SIEM, your analysts, anybody who needs to consume these to understand exactly what the data is. And I know I've had so much time in the past where I've spent writing various parsers for logs. This is going to save me a lot of time, and I hope it saves you a lot of time too. So you can see I showed you an access denied, an access granted message. We log a lot of information in here, including not just what the attempt was, but information that we might have about the identity of the person, about the device, and other things. We're really looking forward to hearing from you about what else you'd like to see in these logs, so please do reach out if you have ideas. To wrap up, let's take a minute and talk about pricing. So Ava helps you migrate to Zero Trust at your own pace. So we charge you for every application hour that you have associated running with Ava. We also charge you data processing. So you can get full details on our pricing at our pricing page. As a quick example, if you associate 4 corporate applications with verified access, and each processes an average of about a gig for the month, then for that month you get charged 4 times 24 times 30 app hours and 4 gigs of data processing. Great. Well, thank you so much for coming. I really appreciate you checking this out. Really excited to get feedback on our product. Please do reach out. As Siobhan mentioned, that was Siobhan. I'm Jess. Please do also leave us feedback in the mobile app. We'd love to know what you thought about the talk. And we'd love to take your questions off stage in the hall. So thank you so much for coming.